Okay, let's take a look at this table question. Okay, so in this question, we have results of a survey of a random sample of statistics students. We're asking whether you have a dark backpack or light backpack, and then whether you are right-handed or left-handed. So the purpose is to figure out if your right-handedness has something to do with your backpack color, which you probably already guess is not going to happen. But if you go to the top where you have the Desmos, right? So let's open under resources, and then we want to use the sidebar option over here. So let's do that. Let's first fill out the table margins. So 63 plus 7, that would be 70. I can do that without a calculator. 72 plus 8 is 80. The total here would be 150. Okay, so here 63 plus 72, that's 135, and 7 plus 8 is 15. By the way, one of the things that you should always check to see if this adds up to the grand total, but also if these two also add up to the same total, that would be a nice double check to make sure you are not mistyped something or miscomputed. Okay, so it looks like it's 150 is the total. All right, so the next thing we're going to do is take a look at the event A. A student has a dark backpack. Okay, so that would be just favorable over total. Total number of students who have a dark backpack is 70 divided by the grand total in the table. So that would be 70 over 150. However, the answer here should be as a reduced fraction. So don't forget to click on the fraction to reduce it. So that would be 7 over 15. All right, the next question says, a student is left-handed. Well, we need to look at the total number of students who are left-handed, which is 15, and divided by the grand total, which is 150, converting that to a reduced fraction is 1 out of 10. All right, the next question is always the one where a lot of people do not understand. So this and business, the A and B, what does that mean? So it has to be a student has a dark backpack and at the same time, so always add those words. Anytime you're doing this and, you want to add the words at the same time. So a student has a dark backpack and at the same time he or she is left-handed. Well, so left-handed, right? And also dark backpack. Well, where is the intersection? So the left-handed is here, dark backpack is here. So this part, the and part, is going to be these 7 people, and then you're dividing that by 150. So the overlap or intersection of those two events is going to be 7 over 150. I don't think that this is reducible, so we're just going to put it just like that. Now, the last part, that's the multiplication rule. So multiplication rule says, if A and B are independent, then probability of A and B is probability of A multiplied by probability of B. Well, we just found probability of A and B. So now let's multiply these two. So 7 over 15 multiplied by 1 over 10. So also convert that to a fraction. It will give me 7 divided by 150. So as you can see, these two answers match, right? And if they do match and they have to be exact, then over here we're going to say, okay, well, these two things are equal, which means that the events A and B are independent, which should make sense because the color of your backpack should have nothing to do with whether you are right-handed or left-handed.